Hello, Math 142, talking about ellipses, and I'm going to attempt to answer the most questions that I receive over these years from ellipses in next few pages. Right now, we are in page 1 of my explanation. Uh, so this is directly coming from your textbook. An ellipse is the collection of all points in the plane, the sum whose distance from two fixed points called foci, or some teachers pronounce it foci. I'm not sure which one is correct, and it's up to you. Is constant. So let me first fix this and say that this is foci. Okay. So let's look at this ellipse. Okay. The first thing that I want you to pay attention is that this yellow uh, right here, if I call that distance from the center to the edge, to that the vertex on the right hand side, if I call that A, so this one would be negative A. If we decide that this point on the very middle is just the origin or 0, 0. I'm not going to write it because there's no reason. I don't have that much room. And similarly, if I call this part B, then this is minus B. And so if I call this distance right here, this distance right here, C, and actually this would be minus C, and this would be C. Okay, let me erase some of this because it's getting really crowded. And let's call this right here D1, since this is the distance, distance between this point, since C and this C and minus C are equal, they're the same size, minus B and B are the same size, therefore D1 and D2 are the same size. So now I don't have room. Let me go and take this, let me take this triangle right here outside of this ellipse and just look at that. Going to the next page, page 2. So this part right here was called C, and this part was called B. And of course, this part right here, I had it as D or D1. But look, by the definition, D1 plus D2 equals 2A. Let me go back to the first page, okay? So by the definition of ellipse, that if, so suppose if you think of these 2 points right here, pretend that this is a nail right here, and this is a nail right here, okay? And you are just having like a dental floss around these 2 nails, and you pull it apart and you just draw an ellipse, which I hopefully got a chance to watch a previous video that was awesome and wasn't made by me. Anyways, so by the definition of ellipse, D1 plus D2 is the same as this major axis, the blue line here, which we call that major axis. Major axis, this blue line. And this one, the vertical blue line, this here is called minor axis. So by definition, okay, this distance, let me make this thicker, this major axis, which is the addition of, which is this A, another A on the left-hand side, so it makes it 2A, is the same as saying D1 plus D2. So if you press on D1 and D2 and you make it flat, press it all the way down, it'll be the same size as, twice A. Let me go to the next page again. So if that's the case, then D1 has no choice to be the same size as A, and D2 has no choice but to be the same as A. And so let me just go ahead and now erase this and this. So now that we replace A or D1 by A, look at this right triangle. I have C squared equals A squared minus B squared. Simply because in this case, my A happens to be the hypotenuse of our drawing. And that's the most common mistake students make, that because we are so used to say A squared plus B squared equals C squared. And that's the most common, at least in my experience, most common mistake that students make. So please, please, please keep that in mind, that when it comes to ellipses, C squared equals, excuse me, C squared equals A squared minus B squared. So now, having said that, let me go to page 3. There are 4 things that you need to remember. If you have an ellipse whose center is here at the origin at 0, 0, at 0, 0, the center is at 0, 0, and the major axis is along the x-axis, the larger axis, the major axis is along the x-axis, then this is the equation of that ellipse, that x squared over a to the second plus y to the second over b to the second equals to 1. And this case, this a is a larger, bigger number than b. Okay, and it's a good time for me to tell you that if a and b are exactly the same number, then it's a special case of an ellipse, which is a circle. But it's, and you'll see some in your homework anyways. So once again, a circle is a special case of an ellipse, which a and b happen to be the same. So, so the let me, we'll talk about it more. I might run out of room. Okay, let me go to the next page, page 4 in here. Now, if you have an ellipse that, again, the center is here at 0, 0, but the major axis is along the y-axis. So it's elongated radically. Then notice that y squared and x squared switch places. So here you have y squared or a squared plus x squared plus over b squared equals to 1, with understanding that a is greater than b and b is of course greater than 0. So notice that in this case, the larger number happen to be under y squared. Let me go to the next page. Now, what if you have an ellipse, okay? What if you have an ellipse whose center is just somewhere that is not in, so let's say if this is my x and this is my y. So notice that the center of this ellipse is nowhere near the origin. So what's the equation of that? Okay, once again, the major axis right here is along the, or parallel to the x-axis. So what's the formula? Is x minus h, quantity squared, over a to the second plus y minus k, quantity squared, over b to the second equals 1. With the understanding that the foci of this ellipse are the left foci is at h plus c, comma k, and then h minus c, comma k for the right side foci. And a is greater than b, and b is greater than 0. And one last case that we have is if you have an ellipse that is elongated vertically. So let's say, how about if I have my x-axis in here And let's say I have my y-axis in here. Notice that the center of this ellipse is nowhere near the origin. So what's the formula for this one is x minus h quantity squared over b to the second plus y minus k quantity squared over a to the second equals 1. With the understanding is that a is greater than b and b is greater than 0. Some textbook rewrite this as, uh, let me give myself a little bit of room. Some textbook rewrite this as uh, y minus k over quantity squared over a to the second plus uh, x minus h quantity squared all over b to the second equals 1. And so since I have, the sign is right here, I have addition, it doesn't matter which one you write first. 2 plus 4 is the same as 4 plus 2. So the only thing that you have to remember is that the larger number would be under y in here and in here. So a is greater than b, and of course b is greater than 0. I will do a few examples for you right after this video, and let me know if you have any questions, and I'm going to upload a few examples for you. Thank you.